Welcome to The Explainer. Today, we're diving deep into the 5th century to meet a true scientific revolutionary. We're talking about a man whose ideas about mathematics and the cosmos were so incredibly far ahead of his time, they almost feel like they've been beamed back from the future. His name was Aryabhata.
So let's just start with this one statement. It was made over 1,500 years ago, and it is just stunningly precise. If you do the math, this simple ratio gives you a value for pi of 3.1416. That's accurate to 4 decimal places. But, here's the real stroke of genius. Aryabhata himself knew it wasn't perfect. He specifically called it an approximation, which hints at this mind-bending concept of irrational numbers, centuries before it was formally proven in Europe.
Okay, just a quick heads up before we really get into the weeds here. This is going to be a more advanced look at Aryabhata's work, and we're kind of building on what's already known. If you're looking for more of a 101 level introduction, we actually have another explainer available that covers all the fundamentals.
And all of this brings us to our central question, right? How did one person, writing way back in the year 499 CE, develop a way of thinking that feels so modern? How did his one single text, the Aryabhatiya, manage to challenge the very foundations of the ancient scientific world?
But you can't really understand the work without trying to understand the man, and that's where things get tricky. So who was Aryabhata?
Well, the historical record is frustratingly thin. We know he wrote his absolute masterpiece when he was just 23 years old, which is incredible. But beyond that, so much of his life is just shrouded in mystery and scholarly debate.
And this slide really gets to the heart of that historical puzzle. On the one hand, Aryabhata himself says he was in Kusumapura, a major hub for learning at the time. But then you have later commentaries and the fact that his work became incredibly popular and influential in the south, especially in Kerala, which suggests he might have come from there. It's a perfect example of a shortfall in our understanding. The truth is, we just don't know for sure.
What we do know for certain is this. He wrote the Aryabhatiya, and it is nothing short of a masterpiece. In just 121 incredibly dense Sanskrit verses, he managed to summarize all the known mathematical and astronomical knowledge of his time, and then he pushed it light years forward. So let's dig into how he built this universe of his. It all starts with the language he used, and that language was mathematics. For Aryabhata, this wasn't just about finding answers to problems. It was about creating a whole new grammar to describe reality itself.
Now, he didn't invent zero, but his work absolutely depended on a place value system that used it implicitly. This was totally revolutionary for doing complex calculations. We've already seen his crazy precision with pi. He also basically pioneered trigonometry, creating some of the world's first tables for the sine function. And in algebra, he came up with this brilliant method for solving a really tough type of problem, equations that can have multiple whole number answers.
And one of his most powerful tools for doing this was an algorithm he called the Kataka. The name literally translates to the pulverizer. How cool is that? The name itself tells you exactly what it's designed to do.
And this just shows you how systematic his thinking was. Instead of just trying to guess an answer through brute force, the Kataka method pulverizes a big, nasty problem into smaller, much more manageable pieces. You solve the simplest little piece, and then you just work your way back up to find the solution to the whole thing. It is so elegant and so powerful.
The reach of his work is just incredible. Take the word sine, right? It's a cornerstone of modern math. Well, it started with his Sanskrit term ja, which means half chord. Arabic translators heard this and wrote it as jiba. Over time, that got confused with another word, jibe, which means pocket or fold. When European scholars translated that into Latin, they used the word sinus, which also means fold or curve, and sinus eventually became our English word sine, a direct line right back to Aryabhata across 1,000 years and 3 different languages.
But here's the thing. These mathematical breakthroughs weren't just abstract thought experiments. For Aryabhata, they were tools, and he used these tools to completely recode our understanding of the entire cosmos.
And this is where his rational approach just shines. While everyone else was looking at the sky and seeing mythology, he was seeing physics. The common belief was that eclipses happened because a demon was literally devouring the sun or the moon. Aryabhata just swept all that aside and offered a purely scientific explanation. They're just shadows. It's the shadow of the Earth falling on the moon or the shadow of the moon falling on the Earth. Simple as that.
Then he used this beautifully simple but incredibly profound analogy to explain why the stars seem to move across the sky every night. It's an ideal we all get today.
the relativity of motion.
And that simple analogy led to a conclusion that was absolutely earth-shattering for the 5th century. It's not the heavens that are revolving around us. It's our own planet, the Earth, that is spinning on its axis once a day. This was a direct assault on the geocentric model, a full 1,000 years before Copernicus would argue for the same thing in Europe. Just incredible.
And the list just keeps going. He correctly figured out that the moon and the planets don't have their own light. They shine because they reflect sunlight. His models even hinted at elliptical orbits, which is a key step towards a sun-centered solar system. He calculated the Earth's circumference and was off by less than 1%, and his calculation for the length of a year, while a tiny bit of an overestimate, was still astoundingly precise for an age without any telescopes.
So why does all of this matter so much today? Well, because his ideas didn't just end with him. They set off a chain reaction of scientific discovery that would echo across centuries and continents.
You can literally trace the journey of his ideas right here. First, his work was kept alive by Indian commentators like Bhaskara I. Then it traveled west, translated into Arabic during the Islamic Golden Age. From there, it eventually made its way into medieval Europe. It formed this crucial link in the global history of science. His legacy is so profound that in 1975, when India launched its very first satellite, they named it Aryabhata.
So when you boil it all down, you get these 5 pillars of his genius. He figured out the Earth spins on its axis. He gave a scientific reason for eclipses. He nailed the value of pi. He laid the groundwork for trigonometry. And he developed a powerful new tool for algebra. Honestly, any one of those would have cemented his place in history. The fact that he did all of them is just monumental.
And that leaves us with one final kind of provocative thought. The only reason we know about Aryabhata is because his one little book, the Aryabhatiya, managed to survive all these centuries. It really makes you wonder, doesn't it? How many other brilliant minds, how many other revolutionary discoveries have simply been lost to the sands of time?